Hello and welcome back to Humanizer, where I'm converting the free and open source MakeHuman 3D character creator from Blender into Godot. So last time I added the skin color, gender, age, and race options in the main tab. And this time I added all of the additional micro details that are available, so you can see that you can change the legs and hands. It's kind of hard to see the face features, but it does change those too, so there's quite a lot of options, and I may still cull some of these out, I'm not sure, but I also need to add the macro details for the height and weight and breast, but I'll probably do that in a later video. Next time I want to either fully automate the clothing importation so you don't have to export it from Blender, you can just use the plugin files. And I also need to generate the collision shapes using the bone attachments and the shape keys so that the physics work. But for now, in this episode, I just added most of the rest of the shape keys. So it's a pretty complete character creator at this point. But I put the link to the download in the description, and now I'll show you how I got this to work. First, you'll want to go to the MakeHuman MPFB downloads page and get the nightly build. I'm using the Blender 4, so you'll need to get that version. And download the nightly build, or the latest version would work too, probably. So I won't be distributing these files in the repository. So if you want to generate additional shape keys or change some of the configuration, you'll have to download this yourself. Then in the Humanizer project, I'll make a new folder for MPFB2 plugin, and I'll paste the zip file here and extract. So this folder name will change depending on the date. So I'll just copy the MPFB folder so that it has a static path, and I'll make a folder for the assets in here as well, but I don't need those right now, so you'll just want to copy the zip file into the MPFB2 plugin folder and move it up a level so that you have all of the targets available in the Godot project. And now I want to extract the text files from the gzip. So you can see these are plain text files, but Godot can't read zipped files that weren't made in Godot. So there is a gzip encoder, but it's specific to Godot. So I'll go into the targets folder and use the gunzip command to unzip the files, -R so it's recursive, and star for all. And this will delete the original archive as well. There's a flag you can use to keep them, but I don't need them, so Now, you can see we just have the text files for all of the shape key targets. So there's around 1,200 shape keys included, and I don't want to process all of them. If I can remove some, that would be good. So in Godot, I'll make a new folder to process the shape keys. And I'll make a new scene to clean and merge the shape keys. And I'll attach a new built-in script. So initially, I just tried to use the directory access remove absolute, which takes an absolute path and point it to the data targets asymmetrical folder. This has, like, you can move the jaw left to right or the side of the head up, but I don't really want the asymmetrical targets. But if I run that, you can see that it does not delete the asym folder because it has files in it, and you have to delete everything in the folder first. So I'll make a new function to delete the folder, which takes a string path, and in the directory access documentation, there's a function to iterate over a directory, so I'll copy that. Now, if the found file is a directory, I want to recursively call the delete folder function slash the on the path plus the file name. And if it's a file, then I can use the directory access remove absolute on the path plus file name. And at the end of the function, I want to call remove absolute on the folder, since it will be empty at this point. And I'll change this to delete folder, and remove the trailing slash. So now when I run the clean and merge, you can see that the asym folder has been removed from the targets. So I also want to ignore the genitals, and for now I don't want the breast or the height and proportion macro details. So you can see there's quite a few, because they include a target for each permutation of muscle and age and gender. So I will be adding the other macros in probably the next video, but for now I'll just ignore those as well. And I can just add them back in next time. So that will significantly reduce the number of shape keys. I do need the root macro details folder still. Because it has the base age, race, and gender shape keys. So I'll just get rid of those, and now I want to merge some of the shape key files. So in the ears, you can see there's left and right, but I don't really need to have the asymmetrical shape keys, like I deleted the folder. So there's quite a few of these on the hands as well. You can make one hand bigger than the other, but I don't really need that. So I want to merge the left and right shape keys. So first I'll need to loop over the target files. So I'll open the load shape key data scene and copy the get target files. And I'll make a function to merge shape keys, and that will take a string path and a string file name. So I'll just print the file name for now. And I want to make sure the extension is .target. And also check if the first two characters are L dash. So if the file name .substring from 0 of length 2 equals L dash, then call the merge shape keys. And if the file is a directory, it will call the get target files again. So now in the ready function, after it's deleted all of the folders, so I'll call get target files on the data targets folder. So now if I run the clean and merge scene, you can see that it's printed out all of the target files that are for the left side. So there will be a corresponding R dash for the right side, and I want to get both of those and then merge them into a single file. So it would be, instead of L ear scale depth increase, it would just be ear scale depth increase with both of the target files merged together. So I'll get the merged file name from the file name substring from the second character to the end. And I'll make the merge file with file access.open. So I'll open the path plus the merge file name using write access. Now I want to read the lines from the target file. So I'll copy the new target file from the shape key data scene, and I'll open the path plus the input file name using file access read, and then while the target position is less than the target file .length, get the next line. Now I'll use merge file .store line to store the next line. Then I want to add the data from the right side shape key as well. So I'll set the new target file equal to path plus r dash plus the merged file name. And then I'll loop over that file as well and add the lines to the merge file. And finally, I want to delete the original two files. So I'll use directory access remove absolute on the path plus the file name and the path plus the right side file name. So now when I run the clean and merge, it prints out the shape key names, and in the targets folders you can see now there's only one file for each earlobe shape key instead of the left and right. So that's for the eyes and hands and feet and all of that. So now I moved the load shape key data into the process shape keys and deleted the previous JSON. So I'll set the new target folder to the MPFB plugin targets directory. And I'll set the save path to the process shape keys. So now this will just import all of the data from the shape keys into a single JSON file, since it takes a long time to navigate over all of the different target files. But if I go ahead and run this, it still takes 5 or 10 minutes to process all of the shape keys. So once it's done running, I'll open up the import shape keys to base mesh, and I'll change the shape key data to the process shape keys folder, and I'll run this to generate the base unshaded mesh with all of the shape keys. So you can see it's processing. And now if I open up the generated mesh, you can see that all of the eyes, ears, head, legs, all of the shape keys are now available in the base mesh. And so you can see if I change some of these that it's affecting the base mesh. Next, I'll run the generate shading function, and I shouldn't need to change anything in the script. This just uses the surface tool to generate tangents and normals from the existing shape keys from the import mesh. So I'll let that finish. Now I can't add the eyes to the base mesh until I generate the eyes shape keys. So I'll open up the clothes generator, and I need to change the shape key folder to the process shape keys. And in the editor, I'll change the clothes name to the high poly eyes, so you can see it's already set. But if I reset it, it'll be the female casual suit. So I'll set the high poly eyes and run the generate clothes mesh which will add all of the shape keys and generate the shading for the clothing and other equipable assets like the hair and teeth. So you can see that it's processed all the shape keys, and once it's done running, I'll open up the add eyes to base mesh scene. So now I have the shaded human and the eyes with all of the same shape keys, and this just adds the eyes as a second surface on the array mesh. So I'll run that. And now if I open up the character menu, it shouldn't throw any errors, but you can see that the clothing does not fit, of course, so I'll need to regenerate all of the other clothing items and the skeleton data. So I'll run the generate clothes mesh for the female casual suit 2, the male casual suit 4, and the male and female elegant suits as well. Once it's done generating all of the clothing meshes, if I open up the clothes demo, you can see that the clothing fits on the character, but the skeleton isn't updating correctly. So, but you can see that the clothing works. So now I need to rerun the load skeleton data scene, and I need to change the shape key data path to the process shape keys / shape key data, and I copied the base mesh vertex groups and rig.mixamo.json files into the build skeleton folder, but I can delete those and point these at the MPFB2 plugin folder that I copied in instead. So I'll get the base mesh vertex groups from the data mesh metadata folder and the rig from the data rigs standard folder. So now I can run this to regenerate the skeleton data. And now if I reopen the clothes demo, since it loads already, now you can see that the skeleton is matching up with the 3D mesh, and the clothes still work as well, and the animations are working. So that's all good. So now the character menu is working again as well, as you can see. And I want to add the additional tabs in the menu next. So I'll make a new scene to generate the tabs, and go ahead and save that in a new folder in the character menu. Then I'll need to add a new tab container, which will create a tab for each child control node. And I'll rename that to menu and make it full screen. Then I'll attach a new built-in script to the tab generator. Now I want to make a new tab for each folder in the data targets folder in the MPFB plugin. So I'll copy the directory contents example function from the directory access documentation and rename it to make tabs, and then I'll call the make tabs function on ready and give it the targets folder. So if it finds the directory, I'll print out the file name, and otherwise if it's a file, I'll just do nothing. So if I run this, it will print out the directory names, and I want to ignore the macro details since those are handled in the main tab, and the images, these could be used in the menu. I might integrate them at some point, but I won't be doing that right now. And I don't need the expression folder either. This has all of the shape keys for the expressions. So I'll make a ignore array and add the expression, images, and the macro details. So if the file is a directory and the file name is not in the ignore folders, then print the directory name. So now you can see that it's excluded those folders, and we just have the details left. Now I want to make a new tab for each folder instead of just printing out the folder name. So I'll make a new function to process the tab, and this will take a string path and the file name or folder name, and I'll make a new VBox container equals VBox container new, and I'll set the name equal to the folder name, and I'll add the VBox container as a child of the menu scroll box. So now instead of printing, I'll call the process tab with the path and the file name. And now when I run the scene, you can see that it has generated all of the tabs at the top. And if the screen is too small to display all the tabs, it creates a arrow on the side so you can select all of them, any of them. Next, I want to add a label and slider for each file in the folder. So I'll make a new function to get the file names, and I'll copy the directory contents function from the directory access documentation. So I'll rename this to get file names from the path, and then I'll make a new array of file names, and if it's a directory, do nothing. Otherwise, if it finds the file, append the file name to the names array. And at the end, return the names array. So if there was an error, it will just return an empty array, which is fine. Otherwise, it will return the list of file names. Then I'll set the target names equal to get file names from the path plus the file name. And I also want to make sure the file extension equals .target so it doesn't pick up the JSON files. Now once it has the target names, I'll loop over each name in the array, and I'll make a new label. And set the label.text equal to the target name. Then add the label as a child of the VBox container. And if I run this, you can see that it's now printing the target names. So I want to remove the .target, which you can do using the get base name. So now you can see that it's removed the .target and we just have the base file name displayed in the menu. So you can see that the VBox container works okay if you have a small number of elements, but for the folders with a bunch of files, it expands to the whole screen and you can't access the menu anymore. So I'll need to put the VBox container in a scroll box equals new scroll container. And I'll add the VBox as a child of the scroll box, and the scroll box as a child of the menu. So now if I run it again, you can see that it's added a scroll bar, and I need to rename the elements because the tabs are just named scroll container and a number. So, and the scroll container, or the tab container uses the node name. So I'll set the scrollbox.name equal to the file name. And now you can see the tabs are named correctly, and you can scroll to see all of the elements. Next, I want to add a horizontal slider for each element. So I'll make a new H slider and add that as a child of the VBox container as well. So now you can see that each element has a slider. And now I need to connect the signal back to the script so that you can change the shape keys whenever the value is changed. So first I'll attach a script to the menu tab container, and I'll make a new function on slider changed, which will take the value, and I'll just print the value for now. Now if I add a horizontal slider as a child of the menu, you can see that the node has a value changed signal, which outputs a float value. So I want to connect to that through the script. So I'll delete the slider, and after I add it as a child, I'll use the slider dot value changed dot connect to the menu on slider changed function. So now if I run this and I change the slider, you can see that the value is being output. Now I need to pass the shape key name along with the value to the function so that it knows which shape key to update. So I need to make a new callable equal to the menu on slider changed function, and then I'll bind the callable, I'll bind the target name, base name as a parameter, and this returns a new callable. It doesn't actually add it to the original one, so you'll have to set that, and then we'll connect to the callable instead. And now this will be passing two parameters, so I'll add the shape key name to the slider changed, and I'll print the shape key name plus the string value. And now you can see that it's printing the shape key name along with the value. So that's working good. Now I want to copy this into the base character menu so that you can see, so I can connect it to the 3D mesh. So I could make the scene a tool and generate the new tabs directly in the current scene, but I think it makes more sense to save it to a new file. So I'll make the save scene equals a new packed scene, then call the save scene.pack on the menu node, and then I'll use the resource saver to save the scene to the generate tabs output.tscn. Now if I rerun the generate tab scene, you can see that the output scene has been created, but it doesn't have any of the tabs or other elements, and that's because the pack scene ignores any subnodes not owned by the given node. So there's an example up here where it sets the node owner to the pack node, and only those two nodes are saved in the scene, but not the collision. So in the generate tabs, you'll need to set the owner for each node after you add them as a child. So I'll set the scroll box owner equal to the menu. And even if you're exporting the root node, you still have to set the owner. I did try that as well. So I'll set it for the scroll box and the VBox and the label and the slider. And now if I run this again and reload the output scene, you can see that all of the tabs have been added and saved to the output file, so they're visible in the editor now. However, the signals have not been connected, so when I change the slider, nothing happens. And I found the answer to this problem on the Godot forum. So he was trying to make an in-game level builder, which sounds pretty cool, but basically the same problem where you're generating packed scenes, and he found that the connect persist is what you need to add to the signal connect. So when I connect to the callable, I can add the connect persist flag, and if I run this again and reload the output, now you can see that the signals are connected in the editor, and if I run the output scene, now it is printing the signal, the shape key name, and the value that it's changed to as it was before. So that's all good. Now I want to copy the tabs into the new character menu. So before I can do that, I need to put the menu VBox container into a tab container. And I'll add menu as the child. Rename the tab container to menu and the VBox container to main. So now we have the tab there. And the signals are all still connected to the main class, but I need to change some of these paths. So I'll add /main. And I'll run the character creator again, just to make sure. Now we have the tab and the skin color, gender, age, outfit, and race are still working. So that's good. So now if I try to copy one of the tabs from the generated output, it throws a bunch of node not found errors from the slider to relative to the hip node. And if I were to paste this under the tab container, you can see that it's renamed all of the nodes. So it's replaced the @ symbols with underscores. So, and the signals were not copied over. As you can see, there's no icon there by the sliders. So I'll delete that. And in the generate tab script, I just want to manually set the slider and label names. So the name equals, and I'll get a new variable for the target name base name. So this is just the file name without the extension. So I can replace, and I'll set the label to the base name plus underscore label, and the slider to base name underscore slider. And now if I run the generate tabs scene again and reload the output, so now the names have the nodes have static names, and if I copy the hip scroll box, it does not throw any errors, and when I paste it into the menu tab container, you can see that the signal was copied, but it's not pointing at anything, whereas in the output, the signal was pointing to the third parent node up. So, and even if I copy the script and attach it to the menu, which I'll need to do anyway. So if I add the menu script and recopy the hip scroll container, you can see that they're still not connected to the menu, and it throws the parameter common parent is null. And if I try to run the scene, so first of all, the menu collapses, and we can fix that by setting the menu tab container layout to and container sizing, so enable the horizontal expand, and then I'll just set the stretch ratio to 0.3. So now it will always be a set width, and so these values are still working, but when I change the hip values, you can see that it's not printing out the value or the shape key name because those signals aren't connected to anything. So I could connect the scroll box containers to the slider signal and make a custom script to pass the signal along, and then I would have to connect to each tab in the menu or the new character script. But I think the best thing to do here is to copy the main tab into the generate tabs scene, and then I'll make the menu a instanced scene from the output. So I'll paste this into the menu. So now if I run the generate tabs scene, you can see that the micro detail tabs have been added after the main tab, and they still emit the signal changed. But if I load the output, you can see that the main tab is not here. We just have the hips, hands, and so on. And that's because the main.owner is set to the generate tabs and not the menu, the tab container. So you can't just set the owner though, because it needs to be recursive. It needs to be called for each child node as well. So I'll make a new function to set the recursive owner on a node. And first I'll set the node owner equal to the menu. And then I'll loop over the child nodes. And call the set recursive owner on each child node as well. And then I'll call this in the ready function on the menu/main. So now you can see that when I reload the output, that the main tab and all of the sliders and labels have now been added to the output scene. So now if I delete the tab container menu from the new character and add the output scene instead, you can see that it's collapsing again. So I'll fix the container sizing in the output, but for now I'll just change it here. And now you can see that the shape key signal is being emitted, and we have all of our tabs here. So this isn't actually changing the character yet, so I need to do that now. So first I want to, in the menu script, I want to add a new signal for the slider changed, and this will have the value and the shape key name. And on slider changed, instead of printing, I'll emit the slider changed signal with the value and the shape key name. And then I'll connect this signal to the main script, and so the human character has a set blend shape value function, but this takes the shape ID. So I'll need to first get the shape key ID equals the human get node body mesh dot find blend shape by name, and find the shape key name, and then I'll pass the human blend shape value to the shape key ID and the value. So now if I run this, you can see that the shape keys are being applied, but they are exaggerated because the scale on the slider is from 0 to 100, and so I'll just divide the value by 100, or you could change the maximum on the slider and the increment as well. But now you can see that the sliders are working, and you can pretty much change any of the shape keys. So the nose, mouth, all of the shape keys. But since I moved the menu into a packed scene, now the main buttons aren't working, so I'll go ahead and fix that. First, I want to copy the menu script to the generate tabs menu script, and I want to set the menu container size, but the option is missing under the layout because you need to change the parent node to a container. I'll just use the base container and set the size to full screen. Then in the menu tab container, you can see the container sizing is here. So I'll enable the horizontal expand and set the stretch ratio to 0.3. Then I want to connect all of the buttons from the main tab back to the menu script. So not the generate tabs, but the menu. So I'll connect the color changed and the gender option selected and the age slider value changed and the outfit item selected and the race item selected. So now we are connected to all of the signals like it was before. Then I need to add a new signal for each button. So for skin color changed, and this will emit a color. And I'll add the gender changed, which will emit a string, and the age changed, which is a float, and outfit changed, will emit an array mesh, and then the race is a string. So for the skin color and age, I'll just emit the past value. But for the gender and race, I'll need to check the option button value. So I'll copy the gender selected and instead of setting the human.gender, I'll emit the gender change signal. And for the race changed, I'll copy the race selected from the character menu. So if the index is 0, the race is Caucasian. If it's 1, it's Asian, and if it's 2, it's African. So instead of setting the human.race, I'll emit the race changed signal. And I'll use the human character instead of the human. So this will emit the race string. Then when the outfit is changed, since I have to change the clothes when I change the gender as well, I made a separate function. So I'll get the clothes option, and the gender from the selected gender. And so 0 corresponds to male. So if the gender equals 0, and instead of setting the clothes, I'll want to emit the outfit changed signal. And this loads the casual suit array mesh and I also want to update the age value when I change the age slider. So I'll change this path to the age label. And it turns out the base container did not work, so in the character menu I have an HBox container as the parent. So I'll just change it so that I know that it works. And this is set to full screen. So now if I run the generate tabs, and reload the output. Now in the new character, you can see that the functions are now available. Now I want to connect the menu changed signals to the new character root node. And for the age, so basically I'll just set the human value equal to the signal value. And I can get rid of all of the other functions since I'm handling it in the menu script instead of in the main script. And I'll use the set clothes for the clothes mesh. Now I'll probably want to hard code these signals on the ready function, but since the scene updates when you save it, you don't really have to delete the scene and add it again. So it's probably safe just to leave these connected as signals. But now if I run the character creator menu, you can see that the options in the main tab are working now. So this all works. And as well, all of the sliders in the menu are working. So you can change pretty much everything if you really want to. It's hard to see some of these since you can't turn the character yet, but basically that's all working pretty well, and I still need to do some work on the micro details, like I want to merge the increase and decrease sliders into a single slider since these will be mutually exclusive, and I need to rename these to be more human readable. And it looks like some of the trans keys are asymmetrical, so it's like moving it left and right instead of symmetrically. So I might need to remove some of those as well, but for now this seems to be working, and I'll leave it here. Thank you for watching and have a great day.